Okay. Again, okay, as soon as we see a cosine, we know that we're probably trying to force this to fit the mold of cosine something minus 1 over something will go to 0. So how does this look? Well, it's supposed to have a minus 1 in it, and instead it has a 1, so apparently there's a factor of minus 1 that we have to worry about. Let's get that fixed, and then we'll see what else is wrong. If we take out a minus 1, we are left with cosine 2 theta minus 1 over theta. That's looking good. The other thing that has to happen is whatever the argument of this cosine function is must match our denominator. So here we have 2 theta, which we can't really change, except for a couple of really weird trig identities I don't want to get into. So it would be nice if there were a 2 down here. Well, that can be arranged. We can put a 2 there. We can just magic up a 2, provided that we put a 2 in our numerator also to keep things even. So now we have this piece. That's a good fit for our limit formula, which says cosine something minus 1 over something goes to 0. And that makes this kind of a boring limit because it ends up being negative 1 times 0 for the middle chunk times 2, and all that comes out to 0. Done. Now, what are they doing with this? We have a tangent in here, and we have exactly 0 limit formulae that have anything to do with tangents, so that's going to be some trouble. There must be some way we can fix that. We have a sine, and we know that the sine over x might turn into something. If we put 0 into this, we've got trouble because we get division by 0, so we can't just evaluate it as is. My first idea is tangent is equivalent to sine over cosine. So if we were to write it that way, we might be able to find a common factor that'll allow us to squirm our way out of here. Let's see if we can do that. Basically, I'm thinking having 3 trig functions is kind of bad. Having 2 is somewhat better, so let's see if that helps us in any way. Instead of tan x, I'm going to say sine x over cosine x. And then we have minus, I'm not changing anything else. And all that is over x cosine x. We have a common factor of 5 sine x here. I think there might be some hope for that. If we pull out 5 sine x from our numerator, we are left with 1 over cosine x minus 1 all over x cosine x. Now, I'm not worried about any of the cosines because if x goes to 0, the cosine of 0 is 1. And 1 divided by 1 is 1, so there's really nothing to worry about from any of these cosine parts. They're not the trouble. The trouble is this. The trouble is division by x. That means division by 0. That part's undefined, so this is what has to go. And we can get rid of it, happy to say, because look here. We have sine x over x. So when you're doing one of these limits, there can be a lot of stuff floating around, but keep your mind on what is the part that's actually causing the trouble and making this be undefined. If it's defined, then you're done. If it's undefined, where exactly is the problem? The problem is division by 0, and the 0 is this right here. So all of the work that you do should be focused on getting rid of this one little piece. And all this other stuff that's swirling around is not the problem, and you shouldn't be worrying about it. This right here, if you get this solved, that's all you need to do to make this thing behave. So we have here, in the limit as x goes to 0, the 5 just sits there. Sine x over x goes to 1. And then we have 1 over cosine 0 minus 1, all divided by, and the cosine of 0 is 1. And unfortunately, that means we have 5 times 1 take away 1 is 0 over 1. The whole thing vanishes because of that second piece. We end up getting 0. But 0 is an acceptable answer. It's only division by 0 that we had to fix.